In this video, we are going to see linear programming problem using Big M method. The Big M method is a modified version of simplex method only. So we can use the same simplex algorithm to solve this Big M method. There is no much difference between simplex method and Big M method. In simplex method, it contains lesser than or equal to constraints. So in that case, we need to add slack variables, that is plus s. This we have already discussed in the simplex method in a separate video. Now we are going to see Big M method, which contains greater than or equal to constraints. So in case of greater than or equal to, we need to do two things. First thing, we need to subtract surplus variables, that is minus s, and we need to add artificial variables, that is plus a. Let us see the problem using Big M method. See the problem. Solve the following linear programming problem using Big M method. Minimization z is equal to 7x1 plus 15x2 plus 20x3 subject to 2x1 plus 4x2 plus 6x3 greater than or equal to 24. And second one, 3x1 plus 9x2 plus 6x3 greater than or equal to 30. x1, x2, x3 greater than or equal to 0. So these are the two constraints. This one is objective function. So this problem is minimization problem using Big M method. The first step is we need to subtract surplus variables and we need to add artificial variables in the two constraints. Before that, we need to write the objective function. That is minimization z is equal to 7x1 plus 15x2 plus 20x3 subject to the constraint. Subject to the first constraint is 2x1 plus 4x2 plus 6x3. So in order to balance the equation, we need to subtract surplus variable 1 and add artificial variable 1 in the first constraint is equal to 24. In the same way, in the next constraint is 3x1 plus 9x2 plus 6x3. So here also greater than or equal to no. So in order to make it equal, just subtract surplus variable 2 and add artificial variable 2 is equal to 30. And what are the variables are there? x1, x2, x3, we have subtracted 2 surplus variable, no. So s1, s2, and we have added artificial variables 2, a1 and a2 greater than or equal to 0. Okay, so here we have done two things. First thing is we have subtracted surplus variable and we have added artificial variable. The same thing need to be added in the objective function. Okay, so in the objective function is minimization z is equal to 7x1 plus 15x2 plus 20x3 and we need to add, that is the for surplus variable we need to give positive 0. Okay, the value is positive 0. So 0 s1 plus 0 s2. For artificial variable we need to give maximum positive value, that is m a1 plus m a2. M denotes maximum positive value. See, these artificial variable are included in the model just to solve the model. Okay, and in the final solution, these artificial variables should not be available. Let us see the first initial simplex table. Let us see the initial table format. BV stands for basic variables. That is, in this problem we have these variables x1, x2, x3, s1, s2, a1 and a2. So these are the basic variables. CJ stands for coefficient of objective function and CB stands for coefficient of basic variables. So this one is row 1 and second one row 2. Here we need to write solution and finally a ratio. So now let us see how I am framing these things. So BV is basic variables are, these are the basic variables that we have already written. CJ stands for coefficient of objective function. This we can write from the objective function. Look at the objective function 7x1. So x1 is there now, write 7. 15x2. x2 is there, write 15. Next one 20x3. 20. 0 s1. 0. 0 s2. 0. And for artificial variable, the most positive value, that is m. For a1 m, for a2 also m. So these are the objective function, that is coefficient of objective function. These are the basic variables. In this column we need to write the two artificial constraints, that is a1 and a2. So write a1 and a2. What is the coefficient of the basic variables? Look at the objective function. For a1 m, for a2 also m. So write m for a1 and m for a2 also. So now write the first row values. So look at the first constraint, 2x1, 4x2, 6x3 minus s1 plus a1 is equal to 24. 2x1, 4x2, 6x3, s1, that is minus s1. So s1 is there now, right? Minus 1. So in the first constraint there is no s2. Put 0. And in the first constraint a1 is there. So write plus 1. No a2. So write 0 is equal to 24. In the same way, fill all these things for the row 2. For row 2, 3x1, 3, 9x2, for x2, 9, for x3, 6. And there is no s1. So put 0. s2 is there, minus 1. a1 is not there, so 0. a2 is there, so plus 1 is equal to 30. So this is the way to frame initial table. So now we need to proceed further. The next step is we need to find Zj. Okay. So in order to find the Zj, this is the formula to find Zj. So instead of using this formula, let me explain the simple method. So first we need to take coefficient of basic variable of r1 into the first element plus coefficient of basic variable of r2 into first element. Then you will be getting Zj. Take the coefficient of basic variable into the first element plus the second row coefficient of basic variable into first element. We will be getting Zj. That is m into 2 plus m into 3. In the same way, for the next value, m into 4 plus m into 9. m into 6 plus m into 6. For the fourth value, m into minus 1 plus m into 0. In this way, we need to find Zj. Let us see the calculation. For the first one, m into 2, 2m plus m into 3, 3m. 2 plus 3, 5m. For the next value, m into 4, 4m plus m into 9, 9m. So totally 13m. For the next one, m into 6 plus m into 6. So 12m. Next value, m into minus 1 minus m plus m into 0, 0. So value minus m. Next one, m into 0, 0 plus m into minus 1 minus m. Next one, m into 1 m plus m into 0, 0. So plus m. Next one, m into 0, 0 plus m into 1 plus m. Next one, m into 24, 24m plus m into 30, 30m. Totally 54m. Okay, so this is the way to find Zj. So after finding Zj, the next step is Cj minus Zj. So we need to compare Cj and Zj and we need to find the difference. That is, the formula is Cj minus Zj. So look at the first value. Cj is 7 minus Zj is 5m. So answer 7 minus 5m. Next value, Cj is 15, Zj is 13m. So Cj minus Zj is equal to 15 minus 13m. Next value, 20 minus 12m. Next one, 0 minus m. Already minus is there. So 0 plus m. So answer is m. Next 0 minus minus m. So minus minus plus. Plus m. Next one, m minus m, 0, m minus m, 0. After finding Cj minus Zj, we need to check the optimality. So what is the optimality condition? For minimization problem, this is the optimality condition. That is Cj minus Zj must be greater than or equal to 0. So all the Cj minus Zj value must be 0 or positive value, that is greater than or equal to 0. Look at the answer. Cj minus Zj, here we have got negative value for three things. The first one is 7 minus 5m, here 15 minus 13m, and here 20 minus 12m. So we did not reach the optimality. So in order to reach the optimality, we need to proceed further. In order to proceed further, the first step is we need to find the key column. For key column, we need to find most negative value from the Cj minus Zj. So look at these three values. Which one is most negative? Minus 13m, that is 15 minus 13m is the most negative value. So this is the key column. So this column is the key column, that is x2 column is the key column. Okay, so after finding key column, the next one is we need to find key row. For that we need to find the ratio. In ratio column, put 24 divided by 4 is equal to 6. For the second row, the solution is 30 now. So 30 divided by 9 is equal to 10 by 3. In order to find the key row, we need to select least positive value. So which one is least positive value? 10 by 3 is the least positive value than the 6. So this row is the key row. This row is the key row. Okay, so now we have got key column. X2 is a key column and A2 is a key row, and the intersecting point is called key element. So the key element is 9, and this one is key row, and this one is key column. So after finding key row and key column and key element, we need to prepare the first iteration. In the first iteration, x2 will be the entering variable and a2 will be the leaving variable. In the first iteration, bv and cj remain same. Okay, so now we have to fill row 3 and row 4. Okay, so in the previous initial table, so which variable is entering variable and which variable is leaving variable? x2 is the entering variable and a2 is the leaving variable. Okay, in the first iteration, instead of a2, you need to write x2. x2, what is the cost for x2? 15. Write 15 here. Okay, and a2 is the leaving variable. No, so in the a2 column, you need not find anything. So put dash. Okay, now we need to find the new value in the first iteration. Okay, in order to find the new value, just take the old value divided by key element. Okay, for the leaving variable, okay, you need to find the old value divided by the key element. That is 3 by 9, 9 by 9, 6 by 9, 0 by 9, minus 1 by 9, 0 by 9, 1 by 9 and 30 by 9. In this way you can find a new value for row 4. So first one 3 by 9, that is 1 by 3. 9 by 9 1. 6 by 9 is equal to 2 by 3. 0 by 9 is equal to 0. Minus 1 by 9 is equal to minus 1 by 9. 0 by 9 is equal to 0. Okay, and 30 by 9 is equal to 10 by 3. Okay, we have got the new value for row 4. Okay, this is the way to find new value for row 4. Now we need to find the values for row 3. In order to find values for row 3, there is a formula. The formula is old value minus key column value into key row value divided by key value. Okay, so look at the table, initial table. For example, for the first value, old value is 2. Okay, so 2 minus correspondent column value is 4. Okay, into correspondent key row value is 3 divided by key value is 9. Okay, this is the formula to find the new value. So instead of this formula, you can find this formula. That is old value minus key column value into row 4 value. Okay, this we have already applied in the previous step. That is key row value divided by key value. Okay, so this is denotes R4. So you can simply take the R4 value. Let me explain with the problem. Old value minus key column value into row 4 value. Look at the initial table. Old value is 2 minus key column value is 4 into row 4 value is 1 by 3. Again I repeat, old value is 2. So 2 minus key column value is 4. So 4 into R4 value 1 by 3. 2 minus 4 into 1 by 3 is equal to 2 minus 4 by 3 is equal to 3. 6 minus 4 is equal to 2 by 3. So the new value is 2 by 3. 2 by 3. In the same way, for the next value, old value is 4, corresponding column value is also 4, and the new value, row 4 value is 1. So formula is old value 4 minus corresponding column value 4 into our 4 value is 1. So 4 minus 4 is equal to 0. 0. In the same way, for the next value is old value is 6. So 6 minus corresponding column value is 4 into R4 value 2 by 3. 6 minus 4 into 2 by 3. So 6 minus 4 2s are 8. 8 by 3. LCM 18 minus 8 is equal to 10 by 3. New value is 10 by 3. 10 by 3. Okay, for the next value, old value is minus 1 minus key column value 4 into row value. Row value is 0. Minus 1 minus 4 into 0 is equal to minus 1. Minus 1. For the next value, old value is 0. So 0 minus 4 into minus 1 by 9. Is equal to plus 4 by 9. For the next value, old value is 1. 1 minus column value 4 into new row value 0. 1 minus 4 into 0 is equal to 1. 1. Okay, for the solution, old value is 24 minus column value 4 into new row value 10 by 3. So 24 minus 4 into 10, 40 by 3. So LCM 3. 3 into 24, 72 minus 40 is equal to 32 by 3. 32 by 3. See, here the value is, the basic variable remains same and the coefficient of basic variable also remain same. So this is the way to frame first iteration table. So after framing all these things, the next step is you need to find Zj. Okay, in order to find the Zj, you can follow the same procedure what we did in the initial table. For the first value, m into 2 by 3 plus 15 into 1 by 3. The answer is 2 by 3 m plus 5. Okay, for the second value, m into 0, 0 plus 15 into 1, 15. Next value, m into 10 by 3, 10 by 3 m plus 15 into 2 by 3 plus 10. Next value, m into minus 1 plus 15 into 0. So minus m. Next value, m into 4 by 9. So 4 by 9m plus 15 into minus 1 by 9. So minus 5 by 3. Next value, m into 1 m plus 15 into 0, 0. The answer is m. Okay, in the same way for solution, m into 32 by 3 plus 15 into 10 by 3. The answer is 32 by 3m plus 50. After finding Zj, the next step is we need to find Cj minus Zj. So look at the first value. The formula is Cj minus Zj. So first value is 7. 7 minus 2 by 3m plus 5. So you cannot subtract this value from 7 because it's a here we have m value. So we can subtract only 5 from 7. Okay, the formula is Cj minus Zj. So we'll be getting minus 2 by 3m plus 2. That is 7 minus 5 will be getting 2. For the next value 15 minus 15 will be getting 0. For the next value 20 minus 10 by 3m plus 10. The same way we cannot subtract this value. Okay, from 20 we can subtract only 10. Okay, the formula is Cj minus Zj. No. So the answer is minus 10 by 3m plus 10. That is 20 minus 10 will be getting 10. The next value is 0 minus m. So we will be getting plus m. Next value 0 minus 4 by 9m minus 5 by 3. The same thing is applicable here also because we have a m value here. So the answer is minus 4 by 9m plus 5 by 3. Okay, again I repeat 0 minus 4 by 9m minus 5 by 3. So minus into minus we will be getting plus value. The next value m minus m 0. After finding Cj minus Zj, we need to check the optimality condition. What is the optimality condition for minimization problem? All the Cj minus Zj value must be greater than or equal to 0, which means we need to get either 0 or positive value. But in this iteration, we have got negative values for 3 things. So we didn't attain the optimality. So we need to proceed further. In order to proceed further, we need to find key column, key row and key element. For the key column, we need to find most negative value. So which one is most negative value? This one is most negative value. So this column is a key column. Okay, after finding key column, then we need to find the ratio in order to find key row. For the first row, 32 by 3 divided by 10 by 3, which means 3 by 10. The answer is 16 by 5. Okay, for the next value 10 by 3 divided by 2 by 3, that is 3 by 2. The answer is 5. In order to find the key row, we need to select least positive value. So which one is least positive value? So this value is the least positive value when compared to 5. So 16 by 5 is the least positive when compared to 5. So this row is a key row. After finding key row and key column, this intersection point is the key element. So x3 is a key column and a1 is a key row and 10 by 3 is the key element. Okay, so according to this iteration, x3 is the entering variable and a1 is the leaving variable. So these are the two things is very important in order to frame iteration 2. See the iteration 2, basic variable and Cj values are remain same. Now we need to frame R5, that is row 5. Okay, so in the previous iteration, so which one is entering and which one is leaving variable? X3 is the entering variable and A1 is the leaving variable. So instead of A1, we need to write X3 and X3 value is 20. Here we need to write 20 and here we need to write X3. For this value, take the old value divided by key element, that is 2 by 3 divided by 10 by 3, 0 divided by 10 by 3, 10 by 3 divided by 10 by 3, minus 1 divided by 10 by 3, 4 by 9 divided by 10 by 3. For A1, you need not write anything. Why? Because A1 is the leaving variable. You can put dash. For solution, 32 by 3 divided by 10 by 3. So this is the procedure to find the row 5 values. For row 5, entering variable is x3. Okay, the cost is 20. Okay, for the new value, you can apply the simple formula. That is old value divided by key value. 2 by 3 divided by 10 by 3 is equal to 1 by 5. Then 0 divided by 10 by 3, 0. Then 10 by 3 divided by 10 by 3, 1. Minus 1 divided by 10 by 3, minus 3 by 10. Then 4 by 9 divided by 10 by 3, 2 by 15. For A1, A2 dash. For solution, 32 by 3 divided by 10 by 3 is equal to 16 by 5. Okay, so now we have got row 5 values. Now we need to find row 6 values. So for row 6, basic variable is x2 as it is. The coefficient of x2 is 15. So x2 15. Now we need to find a new value for row 6. So there is a formula to find out row 6. Look at the formula. Row 6 value is equal to old value minus key column value into row 5 value. So for the first value, old value is 1 by 3 minus key column value 2 by 3 into row 5 value 1 by 5. 1 by 3 minus 2 by 3 into 1 by 5. Answer is 1 by 3 minus 5 3 is 15. 2 into 1, 2. So LCM 15. 5 times 1 into 5, 5. 5 minus 2 is equal to 3 by 15 is equal to 1 by 5. So new value is 1 by 5. For the next value, old value is 1. 1 minus corresponding column value, same thing, 2 by 3 into R 5 value, that is 0. 1 minus 2 by 3 into 0. So 2 by 3 into 0 will get 0. So the answer is 1. So new value 1. For the next value, old value is 2 by 3 minus corresponding column value, same thing, 2 by 3 into row 5 value is 1. 2 by 3 minus 2 by 3 into 1. So 2 by 3 into 1, 2 by 3. 2 by 3 minus 2 by 3 is equal to 0. Okay, for the next value, old value 0 minus corresponding column value 2 by 3 into row 5 value minus 3 by 10. Old value 0 minus column value 2 by 3 into row 5 value minus 3 by 10. So 3 cancel. 1 by 5. 1 by 5. Next one, old value is minus 1 by 9 minus column value 2 by 3 into row 5 value 2 by 15. Minus 1 by 9 minus 2 by 3 into 2 by 15. So minus 1 by 9 is equal to 3 into 15, 45 minus 45, 2 into 2, 4. So LCM 45, 5 times. So 1 into 5, 5. Minus 5 minus 4. Minus 9 by 45 is equal to minus 1 by 5. The answer is minus 1 by 5. Okay, for A1, A2 need not calculate because these two variables are left. A1, A2 put dash. For solution, old value is 10 by 3 minus column value 2 by 3 into row 5 value 16 by 5. 10 by 3 minus column value 2 by 3 into row 5 value 16 by 5 is equal to 10 by 3 minus 5 into 3, 15. 6 into 2, 32. So LCM 15, 5 times 5 into 10, 50 minus 32. 50 minus 32 is equal to 18 by 15 or 6 by 5. Answer is 6 by 5. Now we have got row 5 values and row 6 values. Now we need to find Zj. So in order to find Zj, just multiply coefficient of basic variable into each element plus coefficient of next row variable into each element. So 20 into 1 by 5 plus 15 into 1 by 5. Answer is 7. Next 20 into 0, 0 plus 15 into 1, 15. 20 into 1, 20 plus 15 into 0, 0. Answer 20. And 20 into minus 3 by 10 plus 15 into 1 by 5. Answer minus 3. Then 20 into 2 by 15 plus 15 into minus 1 by 5. Answer is minus 1 by 3. The next value is 20 into 16 by 5 plus 15 into 6 by 5. Answer 82. After finding Zj, the next step is we need to find Cj minus Zj. Okay, Cj is 7. 7 minus 7, 0. 15 minus 15, 0. 20 minus 20, 0. 0 minus minus 3 plus 3. 0 minus minus 1 by 3 plus 1 by 3. That's all. Okay, now check the optimality. So what is the optimality condition for minimization problem? All the Cj minus Zj must be greater than or equal to 0, which means we need to get 0 or positive value. So in this iteration we have got 0, 0, 0, 3 and 1 by 3. So we have reached the optimality. So this is the final iteration. We have got the optimality solution. The solution is 82. Okay, so now we need to write the x1 value, x2 value and x3 value. Okay, so the minimization z is equal to, the final answer is, solution is 82. Okay, now just apply. We have got x2 value. x2 value is 6 by 5. So 6 by 5. x3 value is 16 by 5. 16 by 5. So x1 value take 0. There is no x1. We have got only x2 and x3. So put 0 for x1. Now apply these value in the objective function in order to ensure the solution. Look at the objective function. Minimization z is equal to 7x1 plus 15x2 plus 20x3. 7x1 is 0 plus 15x2 is 6 by 5 plus 20x3 value is 16 by 5 is equal to 82. We need to get 82 by applying these things. Just find 7 into 0, 0 plus 15 into 6 by 5. So 6 into 3, 18 plus 4 into 16, 64. So answer is 82. So we have attained the optimality. Okay, this is the way to prepare LPP model using Big M method. Hope you all understood this concept. Thank you.